Okay, State-Hooke's law, this was actually generally answered quite well. It is that force is proportional to extension up to the limit of proportionality. Okay, if you write F equals KE, you must define the terms. Okay, even just writing F proportional to E, if you don't define what F and E are, nobody knows. So you must define them. Okay, here, what are two features on the graph that confirm the Springer-Base-Hooke's law over the range of values tested? So most people got this great as well. It's a straight line through the origin. Okay, so use the graph to calculate the spring constant, stating an appropriate unit. Well, our line of best fit goes through the origin, so that can be 1 point. And we are up here at, ooh, that is difficult to read on this, 450 at 35 centimeters. So okay, and the spring constant, actually 1286 if I'm going to round properly, and Newton per meter, or Nm minus 1. And there'll be a range of values that will be acceptable for this. And if I did sig figs, 1300. Okay, so how can this formula be derived from a graph of force against extension? Well, we know that work done is force times distance. Okay, so on a force distance graph, that is work done equals the area under the graph. Okay, and we can look at the fact that work done on a spring is equal to, because of conservation of energy, the energy stored in the spring okay. And then because the graph is a straight line at an angle, is a constant gradient, the area is a triangle, which is 1/2 times base times height, which is 1/2 of force times delta L. There, easy peasy.